Hello everyone. In this video we will discuss some more APIs for file handling. The next API is creat. As the name indicates, this API we are using to create the new regular files. If the file does not exist, we can create the new file. The prototype of this API is creat. The first argument, that is a path name, and second argument is mode. The first argument, path name, indicate where we wanted to create the file, means in which location we wanted to create the file. Mode is nothing but we are assigning the access permissions like read, write, execute permissions for user, group and others. So that is we are using. One more thing, the mode underscore t is nothing but it's just like integer type. The return value of this API is file descriptor -1 on error. So as I already told, just we can find it here. The first argument specifies the name of the file to be created. Second argument specifies the permission of a file to be accessed by the owner, group and others. The creat function can be implemented by using open function as. So that means this creat API can be implemented by using open API. That means wherever the creat API, this path name is appears, the automatically open API will be called. That means we are creating the file in write only mode. Okay. Next, read API. As the name indicates, we are read the contents of the file, which means a fixed size of data is reading from a particular file based on the file descriptor. This is the prototype what it is. Here, first argument, there is a file descriptor, second is the buffer, and third one is the byte. With respect to this first argument is nothing but is an integer value. Here the file descriptor is nothing but it is an integer value that is exist in a file table. Based on that only we are retrieving the file. Already highlighted that point what do you mean by file descriptor. The second argument, buffer, the address of buffer holding any data to be read means what kind of the data you wanted to read, so that is located in that particular address location. It is pointed by the buff. The third argument specifies how many bytes of the data are to be read from the file. Okay. Here the return value with respect to read API is number of bytes that data has actually read. That will be the return value. If it is unsuccessful, then -1. There are several cases in which the number of bytes are actually read is less than the data requested. The first one, when reading from a regular file, if the end of the file is reached before the requested number of bytes has been read. For example, if 30 bytes remain until the end of the file and we try to read 100 bytes, read returns only. The next time we call read, it will return 0. Okay, that indicate end of the file. When reading from a terminal device, normally up to one line is read at a time, means single line at a time. Next, when reading from a network, buffering within the network may cause less than one requested amount to be returned. When reading from the 5-bar P4 file, that means usually pipe is holding the certain amount of the data. Okay, that will be written. Next, write API. This API is exactly opposite of read API, which is used to write the contents to a file. The previous one is content reading the file from the file. This one is writing contents to a file. The write function puts the data to a file in the form of fixed block of size referred by a given file descriptor. Just we can go through here. It is also containing the three arguments. One is file descriptor, second one is the buffer, and third one is the size. Here, the first one, file descriptor, is nothing but is an integer value. Second argument is buffer, that indicate address of a buffer that contains data to be written, means where I need to write the data. Third argument specifies how many bytes of the data are in the buffer arguments. Okay. The return value is usually equal to number of bytes of data successfully written to a file. If it is a failure, then it is written the -1. The close API, as the name indicates, this system call can be used to terminate the connection to a file from a process, means is exactly opposite of OpenAPI. So OpenAPI we are using for opening the file. Here we wanted to close that particular file, we are using the close API. The prototype, for prototype, this close API is having only one argument, that is int file descriptor. As I already told, the file descriptor is an integer value, it is written by the OpenAPI. So here file descriptor, and if it is successful, then it returns the 0, unsuccessful it returns a -1. The argument I have described refers to the open the particular file here. Close function, this API frees the used file descriptor so that they can be reused to reference the other files. This is important because the process may open max files at any time, and the close function allows the process to reuse the file descriptor to access more than one open max files. So here open max is nothing but maximum number of files that can be opened by a particular process. The close function deallocates system resources like file table entry, memory, buffer allocated for read and write. So the next API is that fcntl. So as the name indicates, it helps the user to query or set the flags and close on exit flag on any file descriptor. We'll see that one by one. The first argument is again the file descriptor. It is written by the OpenAPI. The second argument, CMD, specifies what the operation has to be performed. The third argument is dependent on the second argument here. So the possible values of command values are f get fl, nothing but f stands for here fcntl API. Return the access control flags of the file descriptor, means access control flags is nothing but what we discuss, O append, O noun flag. Okay, these are the access control flags, what I see that. And set fl, nothing but sets are clears the access control flags that are specified in the third argument, then fcntl API. The allowed access control flags are O append and O non-pop here. So already we know that O append is nothing but we are adding the file at the end of the file content. O non-block is nothing but continuous file operations. Get fd returns the close on exit flag of a file to be referenced by the file descriptor. Its return value is 0. The flag is off, otherwise on. Here close on exit flag is nothing but some of the files we opened but we could not close. So those files will be closed automatically if I specify this flag value here. Okay. Next, set FD. Set circle is the close on exit flag of a file descriptor. Again, it is defined on third argument to fcntl is integer value. If I use the 0, that means we are clearing the close on exit flag. If I am using the 1, that indicate we are setting the flag. Duplicate FD. It duplicates the file descriptors. Nothing but there is a one file descriptor already exists for one file, so that one we can reuse for other files. In that case, I can make the duplications here. So this API is having certain examples, just you can find it here. Useful for changing the access control flags of the file descriptor. Nothing but the first one, that means we are retrieving the current access control flags here. That will be assigned to the current flags variable. Next, again I am using the fcntl, but this time setfl I am using. That means what are the current flags we are having. Along with that, the two flags value we are setting, that is O append and O null block. Okay, and this is with respect to the first two command value of that fcntl API. And similarly, with respect to close on exit flag, we are having this one cout f description close on exit flag. So we are retrieving current status by using f get fd. Similarly, we can set by using this one set fd. Already I told, if we mention 1, that indicate we are setting the current access control flags, nothing but O append and O null block. If I take 0, that means we are clearing the corresponding control flags. The one more use, that is as I told, the info process for this is nothing but duplication concern. We are open the file for read only, then we are closing the standard input. Next, fcntl API we are using, but along with this CMD value is duplication here, then 0 means currently the standard output here, the standard output we are making the duplication here. We'll see that how exactly. See that standard input from 4 now. Means we are closing the standard input file, that is a 0. So we are not reading the content from the keyboard, rather than, because already we closed here. Okay, we are reading the content from 0 here. Now 0 is now pointing to 4, pointing to a 4 file. So what we need to understand with respect to this concept, that this API can be used to set the control flags, and if you wanted to make any file descriptor duplication, then we can use it. So the implementation of duplication file, just we can find it fcntl API, the file descriptor we have to 0. Here also we are having the duplication FD2. Okay, we'll discuss some more APIs in the next videos.